So question 2, and this wasn't hard per se, but it does require some degree of clarity in your concept about the confidence interval. So that's why before I go towards the question, I just want to clarify a few things. So you have your formula for your confidence interval, mean plus minus the particular z value, right? Variance upon n. Now, the thing to be, that you have to be a little clear about here is that what are these two particular symbols denoting? They're not just denoting like mean or sigma square. You have to be a little more specific here. This is population mean, and this is population variance. Now, with your mean, that really doesn't make any difference, because even if you do apply your unbiased estimate, the idea here is the mean, that population mean is always equals to sample mean. Because of that, whatever mean you're putting in doesn't really matter. However, population variance and sample variance don't always, well, it's not so simple with that. And in 9 out of 10 of these questions, they would have given you population variance in the question. So what a lot of people do, they just memorize that. They just memorize that method. When you have your variance, you just put it in the formula and you're good to go. But in a few of these questions, they give you sample variance. And you have to first convert it into population variance and then input it into the into this formula. A lot of people just put it directly and they get the wrong answer. And again, if you remember, so your population variance is n upon n minus 1 into sample variance. A rearranged version of this formula can be found in your MF9 table. However, this particular version isn't there, but so just remember it, n upon n minus 1 into sample variance gives you your population variance, and only your population variance can be used in the equation that we have here for your confidence interval. Now let's read the question. A die is biased. Find the mean and variance of random samples of, okay, the mean and variance of random samples of 70 scores. So n is, let's say, 70 here, are found to be this. Now, again, these are the mean and the variance of the sample. So these are all this is sample mean and sample variance. Now, in the case of mean, it doesn't matter because sample mean is equals to sample into your population mean. But for variance, in order to find out population variance, you need well, n upon n minus 1. Okay, in fact, it's getting a little messy here. Why don't we do it on the next page? Let's just read the rest of the question. You have to calculate a 95% confidence interval for the population mean score. And again, your confidence interval will always be for your population mean, because that's the idea. When you use unbiased estimates, as you're estimating, you'd like a confidence interval to figure out, figure out a particular interval, a particular range, where in this case, if you have 100 samples, 95 of them were, in 95 of them, the population mean would fall within the range. Anyhow, so you have population mean, I believe your n was 70. Your population mean is the same as your sample mean, so that's 3.61. You don't have to worry about that. For your sample variance, your sample variance is given to be 2.7, and the reason I know it's sample variance is because it's written the mean and variance of a random sample, right? So 2.7. Acha, so you first need to calculate your population variance, because remember, you can only use population variance in the formula. So that's n upon n minus 1 into sample variance. N is 70, so 70 upon 69 into 2.70 gives you, what does it give you? Gives you 2.73913. I'm not rounding off here because that would give me it wouldn't give me as accurate of a value. Just round off to 3 significant figures in your final answer. Right. So you now have your population variance, right, which is basically the sigma square that we used to write in the formula. We want our z value, however, and since we're given a 95% confidence interval, if this is 95, this would be 2.5. This would be 2.5. So to calculate the z value for this, you have to, the probability behind this has to be 97.5, and you can figure the z value out from the critical values of your normal distribution table, where you just look for 0.975. So let's get that. We're getting 1.96. Now we just put all of this into our nice little equation that we had. You have population mean plus minus. You have the z value is 1.96. You have root. Now instead of sigma square here, well, sigma square as we used to write it, it means population variance. So I input our nicely calculated population variance upon n should give us 70. You can then just pop that into your calculator and you should get your confidence interval. So that gives you 3.22 to 4.00. Obviously, the reason you're saying this to this is because it's an interval, right? So that was it for this question.